Hello. Now we're going to try to do a finding the power and the probability type 2 error problem for a mean. It's a bit of an unusual problem. This problem is more commonly done with a proportion, but we're going to do it with the mean here. The unusual thing about this is that we're given the sample standard deviation. It'd be easier if we were given the population standard deviation, the sigma, but so let's talk about how to do this problem. So each week Bruno receives a large truckload of apples to make apple pies at his factory. Each time the truck comes in, he takes an SRS of 50 of the apples and finds their mean weight. If he has statistically significant evidence that the mean weight of all the apples on the truckload is less than 20 ounces, he rejects the whole truckload. The hypotheses of the tests he does are shown below right there, and assume the sample standard deviation is 4.4 and alpha is 0.05. Since we're working with a mean and we know the sample standard deviation, we have to use a t-distribution. But think about the sampling distribution of this. And so what's happening is if he gets significantly less than 20 ounces in his sample, if the average of these 50 is not just less than 20, but significantly less than 20, then he's going to reject the whole truckload. So if it was like a little less than 20, he wouldn't do it. So, but if it's a lot less than 20, well, how do we kind of define a lot and a little way? Let's say this is the sampling distribution, a normal curve. It'll be normal because our sample size is bigger than 50. And so assuming that all hypothesis is true, it's going to be centered at 20. And if it gets too far below this, if it gets way out on the tail, if our X bar, see this represents all the possible values of X bar here, our sampling distribution. If our X bar, assuming that all is true, is way out here, causes us to reject the null. How far out? That's what alpha defines. Alpha is the percent of our curve we're rejecting. Since it says less than, we are going less than, and it'll be 5%, 0.05. So we want to find this value here. Now, if we knew sigma, we could use normal CDF, but we don't. We're having to use an X bar to estimate mu and an S to estimate sigma. So we have to use a t distribution. So we have to find the t-score that is right there. And the way we're going to do that is inverse t. So we are going to say inverse t of 0.05. And then our degrees of freedom, since this is a one sample deal, it's the sample size minus 1, which is 49. All right. And so let's see what our t-score is that we get there. And so we shall say second. Now you remember we're going to use inverse t. That's on the distribution menu right above the vars button. So we go second vars, which is distribution, inverse t. And so we are using 0.05, and our degrees of freedom is the sample size minus 1. That's 49. And so there we go. There is our t-score. So that would be negative 1.676551. That is anything less than that would cause us to reject the null. So that's the answer to this first question. What values of your test statistic, and that would be t, would cause you to reject the whole truckload? And so that would be if t is less than negative 1.676551. So then the next question is, what values of the sample mean? In other words, what values of X bar would cause you to reject the whole truckload? And remember, so we'll use our formula for t, our test statistic. Every test statistic has the formula statistic minus parameter over standard error. Statistic is X bar. Our parameter is mu, which we're using mu naught 20. All right. And then the formula for our standard error, of course, is on this next sheet where it says standard error right there. And you go, it says, go to means, standard error for means, and it's S over the square root of n. So going back to this, our formula would be X bar minus mu sub naught over S over the square root of n. So our T, our negative 1.676551, that is going to be equal to our X bar, our sample mean, minus 20, our mu sub naught over, and then our S is 4.4. So this would be 4.4 over the square root of our sample size, which is 50. And so we will use that to solve for X bar. And so I've got that number in there. So I'll just use my algebra skills just to say that number, and then times 4.4 divided by the square root of 50. is equal to, and then add 20 to it. And there it is, 18.9567. So my X bar would be 18.95676, let's say. Anything less than that would cause me to reject the null. So if my X bar is less than 18.95676 would cause me to reject the null hypothesis. So that is our alpha, our 0.05 defines how far on the curve we're going. So, all right, so anyway. Okay, then it says this, unbeknownst to Bruno, a truck comes in that has apples with a mean weight of 17 ounces, shouldn't say hours, ounces. What is the probability of type 1 and type 2 error in the power of the test? Well, first of all, the easiest question in the world is the probability of type 1 error. So the probability of type 1 is always equal to alpha. And that, in this case, that is 0.05, because that was given in the problem right there. So that's easy. Now, the probability of type 2 error in the power are more difficult. So what's happening here, it says that we have this bad truckload that has a mean of 17, which is somewhere over here. So here's the sampling distribution for 17. And the problem is that some of this curve falls in our do not reject region. Everything over here, everything less than 18.95, that is our rejection region. Reject everything over there. And everything above this is we fail to reject. And so type 2 error is when we fail to reject the bad truckload. So it's going to be everything that's above this. All right, so what we need to do, and so in other words, everything that's above 18.9567. Well, what percent of the time is that going to happen with this curve? What percent of this curve is above 18.9567? Now, if we were working with a normal curve, we could just do normal CDF from that to infinity. All right, but with a t-distribution, we have to find the t-score on this curve. So the t-score at this point, our t-test statistic, is in essence our x bar 18.95676 minus 17, the true value there, 17, over, and then 4.4 over the square root of 50. So our t-score is going to be equal to, so let's see what that is. Got that number there. So I'll just say minus 17 is equal to, and then divided by parentheses 4.4 divided by the square root of 50, right, like that. So my t-score is 3.1446, 3.1446. Okay, so there's my t-score. And so type 2 error is going to be the area of this curve above this. And so we would do TCDF. So we will do TCDF from 3.1446 to infinity. And our degrees of freedom is still our sample size minus 1, which is 50, like that. So that's our lower bound, and that's our upper bound. It's our upper bound. So let's see what we get. So TCDF, second distribution. So TCDF from 3.1446 to infinity. And then our degrees of freedom is 49, sample size minus 1, 49. So 49. And so that area would be equal to 0.0014123. So there we go. That is, so there's not, in other words, there's not much overlap at all. So that is what is known as the probability of type 2 error. It is the overlap of the bad curve into the fail to reject region of the good curve. And so that's, and then power is 1 minus that. Power is equal to 1 minus 0.0014123. And so when I say 1 minus that, so that would be 0.998587. And so that is our power. In other words, that's the area of our bad curve that falls into the rejection region. And there you go. That's your example on how to find power and the probability of type 2 error for a mean using T-scores, using inverse T and TCDF. If you have any questions about that, please send them to me. And so good luck on your bonus sheet.